So P5 talks about factoring polynomials. So on day 1, we're going to factor out the greatest common factor of a polynomial, and we're going to factor by grouping. So factoring a polynomial expressed as a sum of monomials means finding an equivalent expression that is a product. So we're going to take some things, some monomials that are being added and subtracted, and then we're going to end up writing it as more than one thing being multiplied. So the goal in factoring a polynomial is to use one or more factoring techniques until each of the polynomial's factors, except possibly for a monomial factor, is prime or irreducible. In this situation, the polynomial is said to be factored completely. So our steps for factoring. You're going to see this a lot throughout this section. So it says, does it have a greatest common factor? The first step, always when you factor, is to look for the greatest common factor. And then our second step is going to be, we're going to count the number of terms. So if there are 2 terms, we could have a difference of squares, a difference of cubes, or a sum of cubes. If there's 3 terms, it could be what I call a simple or an alien. And if there's 4 terms, we're going to use grouping. And then the last step is always to check to make sure it's factored completely. If it is, we're finished. If it is not, then we go back and we do this all over again. All right, so what is the greatest common factor, which is abbreviated as GCF? It's an expression of the highest degree that divides each term of the polynomial. The greatest common factor is what is the largest number or variable that will divide into every single term that we have. All right, so let's look at A here. A says 10x cubed minus 4x squared. When we're looking for our greatest common factor, it has to be a factor of this first term. Otherwise, it can't be common. Okay, so I'm going to use the first term to always help me through. So I see I have the number 10. Well, my other term also have the number 4. What is the largest number that they're both divisible by? A 2. Then I notice I have an x cubed and I have an x squared. Well, remember, x cubed means there's 3 x's being multiplied, and x squared means there's 2 of them. So we can definitely take out an x, and there's 2 of them at least in both of them, so we can take out x squared. You always take out the variable with the smallest exponent, okay? So because they both had an x, we're going to take out an x, and we put the smallest exponent. All right, so I don't have anything else in that first term, so it means it couldn't be in common. So let's divide. Remember, factoring is the opposite of distributing. So distributing, we multiply. Factoring, we divide. So we're going to divide by 2x squared, both terms. So as we go through here, we've got 10 divided by 2, which is 5. We get x cubed divided by x squared. Remember, when you divide, you keep your base and you subtract your exponents. 3 minus 2 is 1. So I could put a 1 there, or remember, if 1 is an exponent, we don't have to. Then we have negative 4 divided by 2, which is a negative 2. And x squared divided by x squared cancels. And we don't have to put anything there because we already have the minus 2 there. I'm done with my polynomial, so close your parenthesis. All right, then double check. Is everything factored completely? Well, 5x minus 2, does it have a greatest common factor other than 1? 5 and 2 do not, so therefore we are factored completely. Now we're going to skip over B. B really doesn't belong on this slide. It's actually on the next slide as well, so I'm just going to cover it when we get there. So look at C. So the only thing we're looking for right now is the greatest common factor because we as a group have not talked about anything else. So I'm going to look at the first term here, and I see it has a number 4. Well, it's got a 4, a 12, and a 32. What is the greatest common factor of 4, 12, and 32? It's going to be a 4. Then I see I have an x to the 5th, I have an x to the 4th, and I have an x cubed. All of them have an x. I can take out an x, and I'm going to take out the one with the smallest exponent. Well, my smallest exponent on the x is a 3. All right, nothing else in that first term, so I'm ready to divide it out. So I'm going to divide each of these by 4x cubed. And now we actually divide it. So we got 4 divided by 4, which cancels. We get x to the 5th divided by x cubed. Remember, keep your base, subtract your exponents. 5 minus 3 is 2. We have negative 12 divided by 4, which is negative 3. And x to the 4th divided by x cubed. Keep your base, subtract your exponents. There should be a 1, or we don't have to write the 1. Then we got 32 divided by 4, which is a positive 8. and x cubed divided by x cubed, which cancels. Then I'm going to check and make sure everything's factored completely. The only thing I could do is maybe a greatest common factor inside the parentheses, and there's not one, so therefore we are finished here. And then let's look at D. D, I have 18, 6, and 24. Their greatest common factor is a 6. Then I see I have x squared, I have an x, and I have an x cubed. They all have an x, so I'm going to take it out with the smallest exponent, which is the 1 right there. And then I have y cubed, y to the 4th, and y squared. They all have a y, so I'm going to take out a y with the smallest exponent, which is a 2. So nothing else in that first term, so we're going to divide each term by 6xy squared. Let's actually divide. 18 divided by 6 is 3. X squared divided by x, keep your base, subtract your exponents. 2 minus 1 is 1. Y cubed divided by y squared, keep your base, subtract your exponents. 3 minus 2 is 1. Then I have 6 divided by 6. Well, 6 divided by 6 cancels, but I still have, it's positive. X divided by x cancels. And y to the 4th divided by y squared, keep your base, subtract your exponents. 4 minus 2 is 2. Keep going. We got negative 24 divided by 6, which is negative 4. X cubed divided by x, keep your base, subtract your exponents. Remember, it's a 1 there, so 3 minus 1 is 2. And then y squared divided by y squared cancels. Done with the polynomial, so close your parentheses. Check what you got. Make sure you can't take anything else out. So if I'm looking at that, what I have in parentheses there, I notice I have a 3, but this is a 1, and this is a 4. They don't have anything in common. I have an x, but the second term doesn't have an x, so it can't be in common. I have a y squared, but the third term doesn't have a y, so it can't be in common either. So we have factored this one completely. All right, so on example 2, the same idea. Remember, terms are separated by plus or minus signs. So even though we do have a minus sign there, this parenthesis is together and it's being multiplied times this 2x. So this is all one term. This is the plus sign that separates it, and this is all one term as well. So look at the two different terms we've got there, and do they have anything in common? Well, they both have an x minus 7 in parentheses. So we're going to take out that x minus 7 and keep it in parentheses. Now we're ready to divide it out. So we're going to divide both sides by x minus 7. Well, here we just have a 2x, and then our x minus 7s will cancel. And then over here we just have a plus 3, and our x minus 7s will cancel. So I'm done with my polynomial, so close my parentheses. Make sure nothing else will factor out, which it won't, and there's our solution. On B, again, we've got two terms, and we notice both of them have a y minus 3 in parentheses. So we're going to greatest common factor that out. So I'm ready to divide it out. So open a parenthesis so we can. We see we have this y outside the parenthesis, so keep it, and the y minus 3 will cancel. We have a negative 5 outside the parentheses, so keep it, and this y minus 3 will cancel. Close your parentheses. Check to make sure you can't factor anything else out, which we can't, so we're factored completely. And then C. We also have two terms. They both have an m plus 2 in parentheses, so we're going to greatest common factor that out. So I'm going to divide by it. Now remember, when we divide, we always put what we have left in another parenthesis there. So notice I have an n cubed not in the parenthesis, and my n plus 2 will cancel. I have a plus 4 not in the parenthesis, and the n plus 2 will cancel. Check to make sure you're factored completely. Neither one of those have a greatest common factor. Therefore, we are finished. All right, so that's greatest common factoring. Now, factor by grouping. So some polynomials have only a greatest common factor of 1. However, by a suitable grouping of the terms, it still may be possible to factor. This process is called factoring by grouping. So if you remember back up at the beginning, I had that slide, and the first step was look for the greatest common factor. The second step was to count the number of terms. If you have 4 terms, it is possible that you could factor by grouping. All right, so let's see how to factor by grouping. So we factor by grouping. The first thing we're going to do is we're going to look for the greatest common factor. And so I'm going to kind of write this going across the top. So the first thing we do, of course, is greatest common factor, just like before. So when I look at A, I have m cubed, m squared, m, but the last one doesn't have an m. So there is no greatest common factor here. So the second thing we're going to do, like it told us, is to count the number of terms. And so when I count the number of terms here, I have 1, 2, 3, and 4. Remember, terms are separated by plus or minus signs. So for 4 terms, that means we could do grouping. Now, that doesn't matter, it doesn't mean it's always going to work out. But if it's factorable, we'll have to use grouping to do so. All right, so for grouping, here's our steps for grouping. So the first thing we're going to do is we're going to split the expression in half. So we're going to take 2 terms on the left, 2 terms on the right, split it in half. Now remember, a sign goes with a number behind it. So that plus just right after my line that I just drew is the positive that goes with the 2m, okay? All right, then we're going to greatest common factor each side. So greatest common factor each side. So look at the left side here, m cubed minus m squared. They both have an m, and the smallest exponent is a 2. So we're going to divide both of these by m squared. So m cubed divided by m squared is m to the first. And then I've got a minus, and then m squared divided by m squared cancels. But we have to put something there because we don't have anything else like we've had before, so you have to put a 1. You're always going to common factor out that sign. So I'm going to take out a positive, and then we're going to greatest common factor this side. What does 2m minus 2 have in common? Well, 2 and 2 are both divisible by 2. And I have an m in the first one, but I don't have an m in that second one. So my greatest common factor is just a 2. So I'm going to divide these both by 2. 2 divided by 2 cancels. And I have that m there. And then we have negative 2 divided by 2 is negative 1. Now notice, we're left with 2 terms, just like we had in example 2. And they have something in common. So our next step, step 3, is a greatest common factor, the whole thing. And so we notice here we have the greatest common factor of m minus 1. It's in parentheses, so I'm going to keep it in parentheses. I'm going to divide both of these by it. I have that m squared there. M minus 1's cancel. I have a plus 2. The m minus 1's cancel. I'm done with my polynomial. So there's my solution. So I'm just going to write it, you know what, I'm going to write it up here so we can read it a little better. So what we had was the m minus 1 that we took out, and we were left with m squared plus 2. So check that, make sure you can't factor any further, which we can't. No greatest common factors. There's no 4 terms. So there is our solution. So let's try B. B, look for step 1, greatest common factor. X cubed, x squared, x, but this one doesn't have an x, right? So there is no greatest common factor. Step 2, count the number of terms. We can see by my underlining there are 4 terms. So 4 terms, can we factor by grouping? Let's find out. So we're going to split this in half. We're going to greatest common factor each side. So x cubed and 5x squared. I can take out an x, and the smallest exponent is a 2. So we're going to divide both of these by x squared. So x cubed divided by x squared is x. We have our plus 5 here. And then x squared divided by x squared cancels. Close your parenthesis. Remember, you're always going to take out that sign, so we're going to common factor out a negative, and then 2x and 10, their greatest common factor is a 2. So we're really common factoring out a negative 2. So we're going to divide both of these by negative 2. Negative 2 divided by negative 2 cancels, and we have our x. And negative 10 divided by negative 2 is a positive 5. Now, so notice, again, just like before, we have two terms, and they both have an x plus 5 in common. Guys, if this was not factorable, the parentheses would not be the same, okay? If we end up with things in our parentheses that aren't the same, first thing we need to do is check to see, did we make a mistake? And if we did not make a mistake, then that means it would not be factorable, or we could say that it would be prime. All right, so anyways, back to this. So notice I have two terms. The parentheses are the same, so that's their greatest common factor. So I'm going to take out the x plus 5. And so we're going to divide by it. So I have an x squared here on the outside. And my x plus 5's cancel. A minus 2 on the outside. And my x plus 5's cancel. So I'm finished with the polynomial, so close the parenthesis. And then check what you've got. See if it'll factor any further. Neither parenthesis has a greatest common factor. The only thing we know how to factor right now is 4 terms, and neither one of them have 4 terms, so that is our answer. All right, so for C, let's do it again. I'm going to erase what I've got so it's not quite so messy looking. So on C, let's look for that greatest common factor, step 1. So I notice I have a 12, a 9, a 4, and a 3. Well, they're not all divisible by anything other than 1. And then I have an a cubed, an a squared, an a, but the 3 doesn't have an a. So that's not a greatest common factor either. So no greatest common factor. Count the number of terms. We can see that there are 4. So let's check if we can factor by grouping. So we're going to factor this individual, each side. So 12 and 9, their greatest common factor is 3. A cubed and a squared. We can take an a with the smallest exponent. So we're going to divide both of these by 3a squared. We do that. 12 divided by 3 is 4. A cubed divided by a squared is a. Negative 9 divided by 3 is negative 3. And a squared divided by a squared cancels. Close it. Bring down the sign. So we're going to take out a positive. 4 and 3, they have no greatest common factor. A, they both don't have an A, so that's not a greatest common factor. So the greatest common factor of this, if I can't take anything out of them, is going to be a 1. All right, so I'm dividing both of these by a positive 1. So 4 divided by 1 is 4, and we still have our A. Negative 3 divided by 1 is negative 3. Two different terms. Parentheses are the same, so we're going to greatest common factor that out. So we're going to divide both of them by 4a minus 3. And we can see we're left with 3a squared plus the 1. And the 4a minus 3's will cancel. No greatest common factors. Neither parenthesis has 4 terms, so that is that's our factoring. All right, and the last one there. So we got 12xy minus 28x minus 15y plus 35. So let's see. Do we have step 1, greatest common factor, 12, 28, 15, and 35. Are they all divisible by some number other than 1? No. All right, then I have an x. 15 doesn't have an x, so can't greatest common factor it. Then we had a y in the first one, but the second one doesn't have a y, so we can't use it as a greatest common factor either. So no greatest common factors here. Step 2, count the number of terms. Well, we can see there are 4 terms, so we can factor by grouping. So 12 and 28, what do they have in common? Well, they're both divisible by 4. Then I see I have an x and an x. I can take out an x with the smallest exponent, which is a 1. And the 12x has a y, but the 28 didn't have a y in that one. It's just 28x, so don't take out the y. All right, so we're ready to divide it out. So we're going to divide by the 4x. 12 divided by 4 is 3. X divided by x cancels, and we still have our y there. Negative 28 divided by 4 is negative 7, and x divided by x will cancel. Bring down your minus. 15 and 35, they're both divisible by 5. Their greatest common factor is 5. And then I see the 15 has a y, but the 35 doesn't. So it's not a greatest common factor. So we're going to divide both of these by negative 5. And so we get negative 15 divided by negative 5, which is 3. And we still have a y. And then 35 divided by negative 5 is negative 7. Two terms, parentheses are the same, so we're going to greatest common factor out the 3y minus 7. When we do, we can see that it's going to cancel. So we're left with the 4x, and that cancels. We have a minus 5, and this cancels. And we check, no greatest common factor in either parenthesis. Only two terms in each one, so we don't know how to factor anything with two terms, so we are finished. All right, so that is the first part of P5, and so we'll continue on with factoring.